Most people still use AI agents by giving one agent at the prompt, waiting for the result, checking the prompt, checking the output, and then prompting again. But that is starting to change. We are moving towards a system where multiple AI agents work together at the same result. They use tools, share information, verify each other's work, and decide what should happen next. So that's where graph engineering comes in. So in this video you will learn what graph engineering actually is, how it differs from prompt engineering, how a graph is structured, how multiple specialized agents will work together, what triggers, nodes, edges, states, loops and verifiers are, how graph engineering work in a complete real-world use case, and the difference between LLM graphs and code as a graph. So let's start with the big picture. So graph engineering is the process of designing the system in which AI agents work together to achieve a goal reliably. Instead of only thinking about the prompt, we think about the complete workflow. What does what? What happens next? What information is passed between steps? What happens when something fails? And how we verify that the final result is actually any good. If you only do prompt engineering, then you tell one agent what to do. So if you have several tasks, then you tell one agent to do every task after each other. So if you want to write a book, for example, first you tell the agent to do research. Second, you want to tell the agent to make a summary of the whole research. Then you tell it to create some bookwork, and then you email it with, for example, a letter, a newsletter. That's all be done with one agent. But if you go with graph engineering, like this picture, you take the system in which agents work. So these are all different agents that all have a specific task to do. And also one thing about this is that you have to fill the prompt with different prompts actually, because you're using 5 different prompts in one prompt. Because first you have to do research, second you have to make a summary, etc. So all the steps are basically in one prompt. And let's say that's not the best practice. So prompt engineering is, there can be triggers, multiple agents, decisions, tools, verification steps, feedback loops and shared state. And prompt engineering is just about telling an AI what to do. And graph engineering is about designing the system which AI agents work in. So let's talk about the first one, the trigger at the left side. The trigger is the one that triggers the request. So a user requests a schedule, a new email, a GitHub issue, an event, etc. After the workflow, the trigger, after the trigger you can have a planner agent. So this agent will plan the whole thing, the whole assignment. It creates different plans. It creates different agents for every piece of the work, and then it's basically set them to work. So basically you have a bunch of agents that each have their own work. Like in a company, you have a human resources person, you have a production employee, you have a sales manager, you have a guy, a salesman who's driving to the customers, you have a purchase guy, etc. So then step 3, after everything is planned, you got the agents that have to go to work. So you have, for example, a research agent, a writing agent, a data agent, a coding agent, an analysis agent. So one agent can have only one clear responsibility. And that means that this these agents are optimized for one specific job, and that also means that they can do the job much better. So this does not mean that you have to create as much as possible agents. It means that you have to give one responsibility to one agent, so it makes the system more reliable. Okay, tools and scripts, the fourth one. The agents can also use tools like APIs, search, CLIs, databases, code, file systems. The tool is not necessarily an agent. The agent is a worker, and the tool is something the worker uses to complete the task. It's important because the first graphic can otherwise look too linear. Okay, verify. So then, after every script has been executed, there has to be a verify step. So one of the most important parts is verification. Instead of letting an agent create something and immediately ship it, another step can be an independent agent that checks the results. Then it gives two outcomes. Or it passes or it fails. If it passes, the graph moves forward to the next section, and otherwise, if it fails, it moves back to the execution agents with what it has to do next to make sure it does pass the next time. So that creates a loop. So until the whole agent passes, it will keep iterating over the loop of execution agents, tools and scripts, verify the agent again until it passes. So now we have the shared state, this one. The shared state is everything the graph needs to remember. So like original requests, the plan, the previous outputs, the errors, the decisions, test result, and the current status. This means the next agent does not have to start from zero. It can continue from everything that's already happened. So, before we move forward, a summary. This is the first image in the architecture. The trigger starts the workflow, and that's the first one. The nodes perform the work, so the execution agents. Then the agent verifies and checks the quality. And then the loop allows the system to retry and improve until it all passes. But this is still quite abstract. So now let's turn into a real use case example to explain everything better. So our goal is to automate and turn a newly published YouTube video into a high quality finished book and deliver it to the right recipients. So at first we have the first step, the trigger. So that can be in this case that a new YouTube video is published that we want to use for our book. So the second step, the planner agent. And the first agent is the trigger. He is starting the signal of the graph. Then the planner agent, he will understand the video, decide which agents are needed to complete the job, determines the order of the work, and will create an execution plan. So after that, you have the agents, the specialized agents, and that will finish the job. So at first we have the transcript agents that will read the YouTube video and extracts the whole text. Well, it extracts the text from the video. Then we have the cleanup and research agent that moves every things we don't need, double messages, etc. So we have a clean, let's say, markdown output. A markdown is a nice text format that can be read by everything. Then we have a book writer agent that's specifically created to turn the content into a nice readable book format, create chapters, write introductions, add examples, create conclusions, etc. And then we have the agent verifier that will compare the book with original video to see if it contains the right content, to check if it's complete, to check the writing quality. That's a specific agent that will act as an, let's say, a really nice language expert. And then we will verify requirements. So if it doesn't pass, we will we will go back to the book writer agent, who will write again in a different way now, and the verifier agent will check if it passes. And then we have a publisher agent that if it's passed, then it will create a final PDF from the text which has been passed, and the next one emails it to the recipients that are in, for example, an Excel list or some kind of other Airtable that can handle tables. So this last step is everything what we need, and then we have also these other things that we need, like the YouTube API. With YouTube API, we can connect to YouTube, so we can actually transcribe the videos. Then we have to search a real database with an LLM, like OpenAI, Gemini, a cloud, etc. Then we need a style guide, and also with the LLM, we use the style guide and the knowledge base for the for writing a book. After that, we need some rules. These are the grammatic rules to know for sure that it writes the right language and the right grammar. And then we need a PDF and storage that, save that in some OneDrive, Google Drive, S3 bucket store, etc. And then we need an email API so we can actually send it to the contact list. And like I said, Excel file, etc. So at the shared state, we have here a web URL that's from the YouTube video, a raw transcript, a markdown file, then a clean transcript that has been cleaned by the LLM, then a research about being able to write the best book, and a verifier that completes everything we still need to check, a revised draft, and then we got a final book. And then we turn it to a PDF, and then the recipients get their book, and we have delivery. So there is one more important decision. LLM as a graph. The workflow can simply be described as an SOP or a set of instructions, and the model interprets how to execute it. Code as a graph, or the graph will be explicitly programmed, so software determines the nodes, branches, retries, and execution order. These are two ways of implementing the same graph. They are not two different definitions of graph engineering. So when to use agents vs code? And not every node should be an AI agent. Use code when the task is deterministic. And deterministic, if you don't know what it means, deterministic means that what you do every time, the outcome will be the same. For example, if you need a number multiplied by 10. If you have the number 5 multiplied by 5 will every time be 25. You don't need an LLM for that. Use agents when the task requires reasoning, interpretation, or flexibility. So, for example, code, fetch data, validate formats, generate files, and run tests. You all can do that with just coding. When you use agents, that's what you need for research, writing, analysis, judge quality, and make flexible decisions. So the best graph usually combines both. Now, the biggest misconception. And this is probably the best misconception about graph engineering. It's not about creating more agents. It's about designing how responsibilities, information, decisions, and feedback moves through a system. And sometimes you need one agent. Sometimes you need 6, 7, 8. Sometimes you need a node. Sometimes a node should not be an agent at all. So you have to be very thoughtful about when to use codes and when to use agents. And if you don't know, just ask your LLM. So first, what's the goal? What should the system ultimately achieve? 2, who does what? Which agent, script or tool or human owns each responsibility? How does work move? What happens next? And where do you need branches or loops? And how do we know the result is good? What verifies any result? What tests? Which guardrails or feedback or loops are required? Well, this is graph engineering at an architecture level. And this same exact idea applied to a real workflow. So prompt engineering is about telling an AI what to do, and graph engineering is about designing the system in which an AI agent work together. And trigger start the workflow, nodes perform the work. Edges connect the work, state remembers what happens, and verifiers check the quality. And loops are allowed to improve the system. And everything works towards one specific clear goal. And once you can build a reliable graph like this, the next question becomes more interesting. What happens when an entire company is running dozens of hundreds of these agents at the same time? I will see you in the next video.